So we're jumping over to chapter 4, section 8, and we're talking about writing sinusoidal functions. So let's look at what those are first. A sinusoidal function is a function that can either be modeled by sine or cosine, because if you remember from our graphing unit that we just did, sometimes we shift a sine graph horizontally and it looks just like a cosine graph, or vice versa. So sine and cosine are just horizontal translations of each other. And for that reason, we can always write both a sine equation and a cosine equation for any sinusoidal curve, any one of these waves that we see. Um, that's a very rough sketch, but any one of those waves that we see can be modeled by either sine or cosine. Sometimes our AP exam will tell us it's got to be a sine equation, and sometimes they will give us the choice. So we will always try to choose the easier graph or the easier equation to write, but if we're not given a choice, we need to practice both. So reminder from our graphing unit, the A coefficient that's in front of sine or cosine dictates the amplitude. And the amplitude, now I have this as half the distance from max to min, but also I usually honestly just think of it as the distance from midline to either the max or the min, it doesn't matter. So remember, for a sine curve, we said we have something like this. So this distance here is A, or from here to the bottom. And then 2 pi divided by b finds the period, which is the length of one full cycle of the graph. We've been looking at that for a while now. Our goal will be to solve for b, because the whole idea of writing this equation is figuring out what all of these coefficients are. All right. Now, another note about b. The value of b, the period of the sine or the cosine graph, whether you're writing that equation, will be the same. So b is the same for sine or cosine. So once you figure out b, that's going to be the value that you put into either equation. A would be the same number, except maybe in one version we have a negative a, and maybe in another version we have a positive. We'll look at that in a minute. C is the phase shift, and we're in our factored form. The b has already been factored out, so C is the true phase shift. Whether you choose sine or cosine, you may need to shift differently depending on where you let the period start. So C will be different for the sine or the cosine equation. So C will be like completely different, not just a positive or a negative, although I guess that could be the case, but usually it's like C is 0 in this equation and it's pi over 2 in this equation. Okay, and then finally, D is a vertical shift, although we have been calling it the midline since it splits the graph in half horizontally. Now, I don't find these values in alphabetical order, so I kind of jump around. So I know I have amplitude, period, phase shift, and midline. We want to find an equation for the sinusoid shown in the graph in both terms of sine and cosine. And this is what our homework is going to be like too. All right, so let's take a look at this. The first thing I like to find is the midline. So remember, the midline, you can either eyeball the midline if that's easy for you to do, or you can always calculate the midline. It is, let's add this for the vertical shift. The midline is the average of the max and the min value. So it's an average, which means it's the max plus the min divided by 2. So let's apply that to our midline right here. The maximum is 7. We're going to add to that the minimum, which is -1, and divide that by 2. So 6 divided by 2 is 3. I like to draw the midline in just to visualize it and kind of make sure. So yeah, the midline is 3. That means that the D value is 3. We have a vertical shift of 3 for our equation, whether it's sine or cosine. Now that we have the midline, we can also find the amplitude. The amplitude is the distance from the max to the midline, or the distance from the min to the midline, however you want to think about it. So from 7 to 3, you can count these boxes, 1, 2, 3. There are 4 units between 7 and 3, or just subtract. So A is 4. Also, this is a positive cosine curve, so A is going to be positive 4. What's the length of the period? So the length of the period, this looks like a cosine graph, right? It completes itself, starts and stops in the same point from 0 to 2 pi. Now our goal is not to find the period, it's to solve for b. So the period 2 pi is equal to our formula for period, which is 2 pi divided by b. Solve for b. So multiply b over here, divide by 2 pi, and we get b equals 1. And maybe you knew that already. We've done a lot of graphing, and if the period is 2 pi, it means that b is equal to 1, but that's fine. We have that. So b will be the same for both sine and cosine. D will be the same for sine and cosine. A may be positive or negative. We'll figure that out in a minute. And then finally, what about the phase shift? Well, you have to think in terms of both functions, so sine versus cosine. For cosine, this looks like a cosine function that's a positive cosine function, right? And it's starting right on the y-axis. So there would be no shift if this were a cosine function. But what if this were a sine function? There are a lot of ways that you can look at this and think about the sine function. You could say, well, the sine function normally starts at the midline. So we're plotting units every one box, right? So the sine function could start back here and complete itself right there. And if that's the case, there's been a shift to the left. Each tick mark is pi over 2. And so what would that mean for c? It would mean that if we want to go left 2, we have a plus pi over 2 as our c value for the sine function. Now you could have also said the sine function starts here and ends here. And if you do that, then you'd say, well, that's a shift to the right pi over 2, but then also I have a negative sine curve. So there are a lot of ways to go about this. Like I said, there are so many correct answers that you'll need to, as you're starting this, you'll need to maybe use Desmos to check your answer versus mine, because we might pick a different period of sine or cosine to focus on. So we officially have enough information to write our equations. It doesn't matter which one you write first. I'm going to start with the cosine curve because this looks like a cosine curve to me. So y equals a is 4, cosine, parentheses, b is 1. I am going to put the 1 in there and the zeros just because I'm not sure for our AP test. I think it will say find the values for a, b, c, and d. So I just want to make sure that I write them out. Okay, so x, and then 0 shift for cosine, so you can write plus or minus 0, it doesn't matter. And then shift up 3, so plus 3. So here's the cosine equation. And then the sine equation. Now I'm going off of this one that started on the left. So it's a positive sine equation, so positive 4 again. Sine, period is still 2 pi, so we have a 1 there. We said c was going to be plus 2. Oh, sorry, plus pi over 2. And the midline was still plus 3. All right. So I don't have the time to do it on this video, but if we were to graph both of these equations, they should land in the exact same spot, and they should look like this if I had this scale in Desmos. There's something called the frequency. This is an easy thing to find if that's just what the AP exam is asking for. So I've seen some multiple choice questions that just say, you know, the frequency of this graph is blah. So first of all, how do you calculate it? Frequency is just the reciprocal of the period. So reciprocal of the period. And what it's showing you is how much of the period is completed per 1 unit. So the frequency is the number of periods, and usually it's like a half period or a third period or something in 1 unit, like from 0 to 1. Now, a lot of times we use the frequency for time. When we get into some applications, we'll talk about like how many periods are completed per second or per minute. But it will help us also on our last example in the notes. So, okay. So let's take a look at the second example now. So we want to write both a sine and a cosine equation for this. So I'm going to start again with the midline. So I'm taking note that the maximum is 16. Add to that the minimum, which is 4. Divide that by 2. The midline is the average of those two extreme values. So 20 divided by 2 is 10. So let's draw in that midline. Now this has, our first graph only showed one period of a cosine function. So this shows more than one period. So let's mark off what one period we see. I'm going to start here. And I'm focusing in on one period of the sine curve to begin with. The amplitude I can see from 16 to 10, the amplitude is a equals 6. So I have that. And the midline, the fact that that was 10, that's D. Remember, that's the vertical shift. The next thing to tackle is the period. So we've got to pay attention to what each of these units actually represent. So 2 units is 6 pi. That means that each box is 3 pi. So I kind of like going in and labeling what I need to. So 3 pi after 12 pi is 15 pi. So the period goes from 15 pi to negative 3 pi. So that's a distance of 18 pi. Remember, 18 pi is not the b value. We have to solve for b. So 18 pi is equal to 2 pi over b. Solve for b by multiplying b to this side, dividing 2 pi by 18 pi. So b is 1/9. So there's our b value. Frequency, I don't need this to write my equation, but just to practice this, that means that the frequency is the reciprocal of the period. So if the period is 18 pi, the frequency is 1 over 18 pi. So just to take a note of that. So each one unit, like wherever 1 is on here, say 1 is right here, the fraction of the period that's completed between 0 and 1 is 1 over 18 pi, that small decimal. Okay, and then what about the phase shift? So I'm looking at this sine curve to begin with. So for the sine curve, it looks like it's been shifted to the left, 3 pi units. So that means that the c value, when I write that in my equation, left is plus 3 pi. Now, if I'm looking at this as a cosine curve, I might choose to look at this peak to this peak. So where does this peak start? It's kind of hard to see this, but you can use symmetry here. This, by my estimate, is 1.5 pi, but it is halfway between negative 3 pi and 6 pi. Halfway between that is 1.5 pi, right? You're 4.4 away from either side. So if it's a cosine graph, the one that I've highlighted, then that's been a shift to the right. What did I just say? 1.5 pi or 3 pi over 2. So that means that if I want to go right, I do minus 3 pi over 2. And you can write 1.5 pi too. That's fine too. All right, now we have enough to write the equation. So let's start with the sine equation first. So y equals, it's a positive sine equation. So positive 6 times the sine of b is 1/9, parentheses, x plus 3 pi. Midline was 10, so plus 10. And the cosine curve, y equals, this is a positive cosine curve. So again, positive 6, sine of b was 1/9. Remember, the only thing that's going to change now is the c value. So it's x minus 3 pi over 2, or 1.5 pi, plus 10. Both of those equations, oops, I wrote sine, sorry. Both of these equations, there we go. Both of these equations model this graph. If you were to plug them into Desmos, they would be the same exact graph and they would have this shape. Now, if you are checking in Desmos, I've got the scale, like this scale is changed compared to the default by Desmos, like counting by single units. So what you're really checking is that your equations match my equations exactly. Okay, now this last example is a little bit harder because, not necessarily because of the midline and amplitude, but on the period. Notice how there aren't a bunch of tick marks here. But what they do tell us is that this point right here is at x equals 0.2. So we'll use that in a minute. But first, let's find the midline. Because remember, on these graphs, for any AP exam, you want to write as much as you can. So we can always calculate the midline and the amplitude. That should be pretty easy for us. So the midline is maximum plus minimum. And you are keeping the negative value because you're finding the average of those two extremes. Oops, except you've got to write the correct numbers. So the maximum is 0.4. The minimum is not negative 0.8. I wasn't being very careful there. Here's negative 0.8. We're actually at negative 0.9. So this is negative 0.5 divided by 2, and that would be negative 0.25. So let's draw that in just so we can see it. So here's negative 0.2, here's negative 0.3. So negative 0.25 is like here. You don't have to draw this in. I just like having that visual. And then that's going to help me. So this is the D value, by the way, minus 0.25. That should help me find amplitude. Amplitude is this distance from the max to the min. So it's 0.4 minus negative 0.25. So 0.40 plus 0.25 is positive 0.65. So that's the A. Okay, now what about the period and phase shift and all of that? So let me erase some of my markings off of here. First, let's talk about the period because we don't have any marks. So I can't just say on this one, well, here's one period of the cosine graph. It goes from here to here. I have no idea how many units that is. So this is where frequency plays a role. What we want to look at is I usually do far left of the graph. How many periods are you getting in within 1 unit? So you can start far left or you can start on the y-axis. Either way for this one. So let's take a look here. Let's say we start far left. So we're looking for when do we land back at that same point. So here's 1. So that's 1 period. 2, 3. So there are 3 periods from x equals -1 to x equals 0. What does that mean about frequency? So within 1 unit, it's the same thing on the right side, by the way. 1, 2, 3. So the fact that there are, for frequency, 3 periods per 1 unit, what we're looking at is what is the length of a period, right? So if I can get 3 in 1 unit, that means that the length of a period is 1/3. Sorry, my pen's not working at the moment. That's not good. So 3 periods per unit is 3, right? Hold on, gotta get this charged. There we go. So three periods per unit is 3. The period and the frequency, remember, they're reciprocals of each other. So if there are 3 periods within 1 unit, what's the length of 1 period? I'm not sure why that says negative. It is 1/3 is equal to the period length. 1/3 of a unit, right? From here to here is 1/3. From here to here, that must be 2/3. And then complete, we get to 3/3 or 1. All right, once I have the length of the period, I can set that equal to 2 pi over b. Multiply b over here. Divide by 1/3. 2 pi over 1/3 is 6 pi, so b is 6 pi. All right, what about the phase shift? So I was using a weird spot to start to mark off the period, but now we're going back to saying, well, where's the sine curve, where's the cosine curve? So again, this is made a little trickier because we don't have tick marks on the axis, but let's just take a look here. So how about we use this x equals 0.2? Because normally I would say, oh, here's a good starting point for the cosine curve. But if they've given me this value, this must be used for something. So what if we start our cosine curve down here? We'll do like a little negative cosine curve. So how far shifted has that been? So this is telling me, well, it's starting at 0.2. So if I look at a cosine curve to begin with, that's been shifted to the right 0.2 units. That means that the c to go right will be minus 0.2. So for cosine, I've got everything I need. For sine, let's find a starting point for sine. So this is going to have to, sine can't start on this 0.2, so this is going to stray a little bit. You could start your sine graph at any of these midline points. I'm going to choose right here. Or maybe I choose, we could go anywhere. How about we just choose one point here? How do I know how far it is from point 2 to this point? Well, remember, the period is equal to 1/3. That's the length of the period. And let's call them tick marks, because that's what I always say in class. How often we plot the 0, 1, 0, -1, those extremes, those are always the period divided by 4. So those are happening every 1/12 of a unit. So if this is 0.2, this must be 0.2 minus 1/12, right? So we want to go figure out what that is. What is 0.2 minus 1/12? Well, 2/10 is 1/5 minus 1/12. That's 12 over 60 minus 5 over 60. That's 7 over 60. Okay, so what are we saying about that? Well, instead of the sine curve starting here, it's sitting over there at, to the right, 7 over 60, because I just subtracted that little 0.2. If I go back 1/12, where would I land? So to the right, 7 over 60. And that would be a C value of minus 0.2. And then I also would need to pay attention to my reflections. So I would have, for cosine, the cosine graph was positive, or was negative, right? We started down here. So it would be negative 0.65 cosine of what's b? B is 6 pi times x minus, what was the shift? 0.2. And then the d value is minus 0.25. What about the sine function? The sine function also from midline open down, so it's negative 0.65 sine. B is the same. This shift we said is going to be not minus 0.2, minus 7/60ths. Okay, so x minus 7 over 60 minus 0.25. I think in my PDF version, I think I started my sine curve back here. So I did 0.2 minus 1/12 minus 2/12 minus 3/12 to figure out what that point was there. And then that would have been a shift left instead of right. So there are a lot of different answers for these. And again, we can graph in Desmos to double check. But even if you're struggling with finding that C value, you want to get as many of these coefficients as you can, because this would be an example of a free response AP question, and we get partial credit for finding some of these values. It doesn't have to be all or nothing. All right, we'll practice this more tomorrow. Come into office hours if you have questions.